Hey everyone, in this video I'm going to be showing how to create a basic relief carving using PixelCNC. So the first step is defining our project's canvas. By clicking canvas properties here, you can set your canvas's resolution, dimensions, and machine 0 or machine origin. You can also set the machine origin relative to the front bottom left of the canvas using these percentage knobs right here. So we can set that to 3% X. You can see that our machine 0 axes right here move over closer to the left edge. If we set all of these to 0, we can set our machine 0 to the bottom front left of our canvas. I tend to prefer using the top center of the canvas as my machine 0, specifically because with the pieces that my wife and I sell online, we have a lot of corner ornate designs that it's very obvious to the eye if something is slightly off center because the distance on one edge, it'll be thicker than the other edge, and it's a bit of an eyesore when that happens. So I try to go everything off the top dead center and find that it's a lot easier to center things that way. So for this project, we will be doing a canvas that is 6 by 6 by 200 thousandths in size. One thing that I wanted to point out is that if you are working in millimeters, you can set your project's units of measure here in the CNC CAM settings dialog, which is under the config menu here. And simply clicking this will toggle between inches and millimeters. Users who use metric instead of inches can follow along with this tutorial as well. Just make sure that you do the conversions or use near equivalent values. That should be fine. This doesn't have to be perfect. This is just to show how to do the thing in PixelCNC. All right, so we have our canvas set up. Now we can load our single image that we are going to use, which is the Tree of Life 3D that is included in the example images that you can find and download on the PixelCNC store page. We load this image in and we can see, well, two things right off the bat is that there is some banding because it is just an 8-bit per channel image, so it can't store these perfect gradients here. We can smooth those out with the smoothing slider right here, hit apply, and we can see that some of that banding gets smoothed out. We do lose a little bit of the detail here on the trunk of the tree, but it's not that big of a deal. The other thing that catches my eye here is that the actual curvature, that it actually is cut off here. So to mitigate this cut off edge here, what I am going to do is grab the corner handle, and if we hold down Control while we're scaling, we have this symmetrical scaling that goes on here. If we hold down Shift while scaling, that retains the aspect ratio of the layer. So because it's a square layer, any size that we set it to, it's going to retain its squareness. In this case, if we hold down Control and Shift, you can see that we retain both the aspect ratio and are performing a symmetric scaling. What's neat about that is that it retains the layer's existing origin. The position of the layer has not moved. All right, the next step is to resolve this little trench that we have here now. This is a product of, I don't know if you noticed, but in Canvas Properties, we also have this Z-fill slider. Select the layer, and it too has a Z-fill slider. This does not affect the inside of the layer. This only affects everywhere outside of the layer. Okay, so now you can see that with our Z-fill increase, we still have a little bit of a cutoff here. One thing we can do, because I know for a fact that everything inside of here is a bit lower than the outer. If looking at this picture in an image editor, there's no points in here that are perfectly white as the outside edges. So I know that we can actually increase the height of this layer. We'll start with 10 thousandths, and we hit apply. And that gives us a much cleaner edge here. It's no longer being cut off. We've brought it in a little bit here. And what's important is that we don't want any of these high points inside of the circular area to be intersecting the top of the canvas. For instance, if I drag this up a little bit more, now we start seeing that we are intersecting the top plane of the canvas volume. We don't want any of that, so I can just undo that here. All right, so that is effectively our canvas that we are creating for this project, for this tutorial. The next step is to define our cutting tools. Now we click the wrench icon here, which brings us to PixelCNC's project tools mode. Right off the bat, you can see that we have 10 tool indices that we can choose from to define our cutting tools in. This means that for a machine that has an automatic tool changer, we can use up to 10 tool slots in our automatic changer. Because my machine does not have an automatic changer, it doesn't matter which indice I use for each tool definition. We can pick one of these slots. First, I will set the name. I want to use a 1/4 inch ball nose to do a roughing pass with. So we will choose the cylinder tool type. The cylinder tool type is for anything from a flat end mill to a ball nose end mill and everything in between. So that includes, let's say 1/4 inch and then a 32nd of an inch radius on that flat end mill. If we want just a plain sharp corner flat end mill, we can have a 0 radius. In this instance, we're doing a 1/4 inch ball nose, so our corner radius is naturally going to also be the radius of the cutter itself. And there we go. And total tool length, this is from the tip of the cutter to the chuck, basically limits the maximum depth that this cutter will be allowed to go into the top plane of the canvas volume. Flute length on my 1/4 inch ball nose end mill that I'm going to use is about 1 inch. None of this really matters because it's all much greater than the actual thickness of our canvas. Because the canvas can only generate cuts within its volume, being that it's only 200 thousandths thick, I will never be going deeper than 200 thousandths with this project. PixelCNC will not generate a cut path that goes outside of the canvas volume. All right, we hit apply. We have our 1/4 inch ball nose definition. Another thing I wanted to show you guys was the tool library here. So you can see that there's this little save disk icon and a little load open folder icon. We can actually save our 1/4 inch ball nose to a tool library that persists between projects. So I can save this 1/4 inch ball nose definition in the library and load it to other slots by clicking the little folder icon when they're selected. And I can load that same definition to other slots across multiple projects. I don't have to redefine all my tools from scratch. If I go like this, let's define our 1/8 inch ball nose, which we are going to use for our finishing pass. Oops. So if I just hit apply here, you can see that it automatically reduces the value down to a 1/16 of an inch. All right, so sometimes I just enter a big value and they're like, okay, automatically tell me what the ball nose corner radius is. All right, so anyhow, there is our 1/8 inch ball nose end mill. Hit apply, done. Oh, you know what? We can save that to our tool library too. Boom. All right, now that we have both of our cutters defined, we can create our first operation. By clicking the little end mill, throwing some chips, we now are in project operations mode where we can define our project's CNC operations and generate their toolpaths. So the first thing we do is click new operation, and we are shown all of the operation types or toolpath types, you can think of it that way too, that we can use. For our roughing operation, we are going to use the parallel carving operation type here. We are going to tell it to use our 1/4 inch ball nose. And let's see, my machine does not have automatic spindle RPM control. Just on the off chance that someday I do have automatic spindle control or run this G code on a machine with automatic spindle control, I do like putting in correct values in here. So 16,000 right now is the slowest that my existing machine can rotate at. So I will use that. For my speed, my cutting feed rate, I will use 50 inches per minute. And my engage, this is the speed that my entry cut is traversed. I'm going to use a ramping cut in this instance. So instead of the cutter just straight down into the material to begin cutting, I will have it ramp down. And the cutting direction, I want to use mixed. This allows it to just switch directions instead of cutting one way, retracting, rapiding over, entering the cut, and then cutting again. Mixed will let it just zigzag back and forth. Cut depth. So because this is a roughing operation, we can let the cutter go to the full depth possible because there won't be any slotting cuts, if that makes any sense. So if this wasn't rounded over here, like this, it's a little bit rounded, if this just dropped off into a pocket, I would probably set this to do 2 layers of cuts. So this would do one pass that only can go 100 thousandths deep, and then it would do a second pass of cuts to get the rest at the bottom there in the second half of the canvas volume. In this instance, it's going to ease into these cuts, and especially with a step over of 50 thousandths. So I'm not worried about letting the cut depth go down 200 thousandths. It won't be a big deal. The minimum depth is the depth below the top of the canvas that cuts must be. So if we set this to 50 thousandths, that means there won't be any cuts above 50 thousandths below the top of the canvas. All right, rapid height, I typically use 100 thousandths unless I have a lot of rapids, at which point that retract to rapid height can be really slow and it can compound total running time very quickly to hours and hours. So I try to keep that as low as possible, but typically about 100 thousandths for most projects. We also want to leave some stock. We are going to leave 15 thousandths. That means that the cutter will not be closer to our canvas surface than 15 thousandths at any point. And link cuts, this allows us to have our mixed cutting direction cuts. Once one cut is completed, PixelCNC will generate a cut path that just feeds into the next cut. It's not going to retract to our rapid height above the canvas, rapid to the next cut, and then do our ramp entry cut, and then begin cutting. It's just going to move right into it. So we hit apply, generate our cut path. All right, so you can see here that we wrap it over to this first cut, and it ramps down, does the cut. Now you can see that the end of this first cut right here is quite a distance from the beginning of this cut over here. So it's not going to link those cuts together. But as we progress around the circumference, you can see that the cuts become close enough together that it does start linking those cuts. This is a bit of just a precaution that PixelCNC takes to not just directly link all subsequent cuts. They must be within a certain distance of each other, and that distance is derived from the cut step over. All right, so looks like we have a pretty good cut path here, nice tool path, and we can simulate it. Let's first give it a name real quick. So we will call this parallel roughing. Now we can go into the simulation mode, click on our parallel roughing operation, and see the finished result. All right, so looks like our tool path is going to be just fine. All right, that looks pretty good. The next step is defining our finishing pass. So we can go back into our project operations mode, click new operation. For our finishing pass, because this is a circular project that we're cutting, I like to use the spiral carving here. And we can see that when we select that, PixelCNC starts drawing this crosshair. This crosshair is the center of the spiral. Because we want it centered in the middle of our tree of life design here, I'm just going to leave it at the default. And radius here controls the maximum radius of the spiral. 0, or if you hit the infinity button here, that sets the radius to 0, and that just tells PixelCNC that there's no radius limit. Just generate it as far out as it'll go across the canvas, and that's that. So for this one, we want to use our 1/8 inch ball nose. We will slow down our feed rate a little bit. I'm going to keep my 16,000 RPM. Make sure you know some rules of thumb or have a speeds and feeds calculator that you can use when entering these values. Otherwise, you will either wear out your cutters too quickly or burn your workpiece. I've had that happen, cutting a piece out with an end mill, and I was feeding just way too slow. It started getting smoky and wood started turning black. I had to sand that for a while. All right, and with this cut path, we're going to do a climb cutting direction. This means that with the cutter spinning clockwise, we want it to move, well, let's say counterclockwise or in a pocket, almost like the cutter is rolling itself around the edge that it's cutting. This tends to produce a better finish. All right, so we, again, because we only have 15 thousandths that we use on our leave stock on our roughing pass, we can just cut the full depth because it's not actually going to be cutting through 200 thousandths of material on the finishing pass. Most of the material's already been removed out by our roughing pass. You step over, we will use a 15,000th step over. Because this is going to be one continuous cut from the middle to the circumference, it really doesn't, we only have one rapid from wherever the tool is. When we hit cycle start, it's going to rapid to the center of the piece and start cutting. And it's going to do one long continuous cut until it gets to the outside, at which point link cuts is irrelevant. So we can just hit apply, and there's our cut path. Now you can see here that the spiral extends up and onto this outer area, the margin here. We don't want that. We want it to stop right at the edge here. So what we can do is set our radius. Well, let's see how big this is. So 1 inch, 2 inch. It's about 2 3/4. We can actually hide the cut path to see better. So we've got 2 3/4. So somewhere between 2.5, 2 3/4. We will go, let's say, 269. All right, and there it is. Now our cut begins here, right above Z0, because we have our spiral centered on our machine 0, and it will spiral out in a climb cutting path and terminates all the way down here in this corner. And then it rapids up to our 100,000th rapiding height, or our safe Z height, and that's that. Let's give it a name. Finishing. Spiral finishing. All right. And we have our name change there. Simulation. You can see our roughing pass, and then we click spiral finishing, and there it is. And we can see a little bit of scalloping in there. I'm going to leave it at 15,000th step over. You can use whatever you want for whatever result you are looking for. I think that this is going to be good. All right, the next step is to export our G-code. Everything looks good. All we need to do now is go File, Export G-code, and this is the Export G-code dialog. So we can either export in our operations individually, so that each operation will have its own G-code file that I can run manually, or I can use this option. Both will produce the exact same result, because I only have 2 operations and each is using a different tool. If I do have an automatic tool changer, I can export my operations combined into one program and then just let the whole machine do everything beginning to end. It'll pull in my 1/4 inch ball nose, rough it out, and then pull in my 1/8 inch ball nose, and then finish it up, and then it's done. My machine is Gerbil based. It's an Arduino running Gerbil. So I'm going to use the Gerbil post processor and open G-code after export. So now we just hit export as to choose where our files go. All right, so I'm going to take these 2 G-code files. I'm going to go run them on the machine, shoot some footage so you guys can see it in action, and then I will show you a couple clips of the process of finishing the workpiece, sanding, painting, staining, etc. Yeah, thanks for watching.
bad. I should have made a better effort to not hit this knot, have it on there. Also, I cut it out a little too fast. That little 1/8" end mill caused the machine to flex away from where it's supposed to be and created a little lip here. Should have used a smaller step down size, especially on this side coming back around on the, let's see, on the bottom there. I bumped the router while it was doing a finishing pass, and it left a couple little ring circles in there.
Don't bump your router when it's doing a finishing pass.
I'm just going to figure out if I want to stain or paint this and show you what that's like.